Hello, this is Team PPC's midterm demo for our CS Capstone class. We are going to be demoing our chess AI app called King's Eye. Right now I am demoing this in the web, but it is meant to be a mobile app. It's just easier to demo this for the web for right now. So what we have here right now is a basic login sign up profile page functionality finished. Sign up page, very straightforward. Just enter your info like so. When you click sign up, it brings us to our homepage. In our homepage, we have a bunch of different games listed, just hard-coded for now. If you were to click on any of these games, it would be able to pop up a chessboard with that specific game's data that you played, and you'd be able to interact with it. Down here, we have our camera module. If you click on it, you're able to take a picture. Right now, I have my camera cover on, but you're able to take a picture, retake it however many times you'd like. And that will feed into our ML model, which will parse that picture and feed back a specific fen string, which is basically just a representation of what it thinks that game state is of different pieces and whatnot. From here, you can go to our profile page. In the profile page, it literally just displays your info. All this info is being stored in our MongoDB database. So if I were to search for that specific email I just created, foobar5, you'll see it shows that data right here. And now if I change the data and save it, if I refresh this database, you'll see, yep, the first name is now Foo and last name is Bar. So that data is updated. Eventually, we also want to have like functionality for updating the profile picture up here, which you'll be able to do by editing down here. You can also reset your password, which through Google Firebase, it will send a reset password link to that email that is associated with this account. Here we have our Firebase authentication, so you can see that foobar5 is the email I just created. We're using authentication to basically manage the user being able to sign in. We have a Google login functionality as well. So like this account was logged in through Google, which I can actually demo right here once I sign out. So if I call sign in with Google, I can choose any account here and they'll automatically sign me in and it will act like a normal account. So just for testing purposes here, if I sign in with that old account I just created, you can see it stores that data so I can sign in with a normal email as well. But yeah, that's the basic functionality for the actual app. Now moving on to the backend and the actual code. So we're running our backend with Node.js and Express. The Node file is running through Heroku, where we also have automatic deployments set up through our GitHub, which is really nice for CI/CD. In our backend, we just have a bunch of API calls, very basic. A bunch of these API calls contact our MongoDB and write and read from it. That's very normal functionality there. Another thing to highlight is that we have our best move endpoint call finished. So if I were to call these few commands that I have listed out here, so this command basically takes in a fen string, and the fen string is just like a representation of a game state that we are getting from our ML model. Through this game state, this Stockfish engine will think and output the best move it thinks it is given with that fen string. This is also another example of a different fen string. One thing to note is that it does take some time to think and render what it thinks the best move is, and that's because we have a specific depth set in our Stockfish engine. If we were to decrease the amount of depth that we are using, it would take a shorter amount of time, but we also don't want to take too long. So that was one of the things that we had to think about, of what depth we wanted to go to and how much time and how to balance those two things out. But yeah, that's the basic stockfish functionality done as well. Another pitfall that I'd like to highlight is that it is kind of annoying that we're using three different services for our app. I think if we were just use like one or two, it would make the process a lot easier. But I think at the same time, we're kind of getting the best of all worlds by using three different apps. So yeah.
So down here, what we do is actually we predict the given the model, we take like one prediction, and I've like coded essentially a way for us to see like the chessboard in a digital representation, just as an array, and I've cut it so that only if like essentially the prediction was correct, then it will be added to these two correct images and correct labels arrays, and we can shoot through the images right here so we can see the representations. So we can see here now, hopefully, yeah, it looks like you can see the chessboard up on the screen. We have this representation, and here's the actual board itself. So this is actually flipped. You should be thinking of this. So as we can see, 9 here is going to be a white rook. That's what the capital R stands for. So this 009 is actually, you should rotate it to land on this back right rook right here. And as we can see, if we go a little bit over from 009, we'll see another white rook, 2 spaces over right there. And then the king is right next to it. And then you have some pawns in front of it, et cetera, et cetera. And we can go on to the next image. And this one is also correct. Number 1 is the black king on this side. We have the white rook over here. 6 is a pawn. There's a pawn right there. And we have 10, 12, 12. So 12, 10 in the middle of the board is the knight. Yep, the white knight. And we can see the white king is 7. Yes, and it's right there. So yeah, we have like a whole list of like correctly estimated images. And I think that's definitely a good starting point for the transfer learning especially.